today we are going to talk about what to do when you're on a Ubuntu, Kubuntu or Debian distribution. You don't have debuginfod and you're using a KDE process that crashes, and you can always reproduce the crash. For instance, I'm going to the main menu of the application, I'm clicking somewhere, and then the application crashes. What to do then? We want to create a issue, a bug report, and in that bug report we will put details about our system. So we're going to say we're on this distribution or this version, and I can reproduce the issue like this. I start the application, I click on the main menu, I click there, and the application crashes each time. So I put inside of the bug report the steps how to reproduce the issue, and then I'm going to be asked, please also put in the bug report a backtrace. So backtrace in the sense of, for each thread of the process that crashes, what functions are being called, what's the call stack. Okay, so again, we don't have debuginfod, so we need to use deb files which are which contains debug symbols, or ddeb files which contains debug symbols. So the ddeb file ends with -dbgsim, and the deb files end with dbg. Okay, and the .dbg files are very few. Like on my Ubuntu 20.10 machines, my machine I only have 4 -dbg.deb files packages installed by default, and there's only, I don't know, 100 -dbg deb packages, and they're mostly for language runtimes. Okay, so the bulk of what are we going to do in order to create a good backtrace is us installing correctly and using files with the extension ddeb, so packages which have the extension .ddeb and end with -dbgsim. Okay, so let's see the procedure. Again, I can reproduce the issue. I know the name of the executable, so let's say that the process kcalc crashes. So for instance, I start kcalc like this, and I click somewhere, and then the application kcalc disappears. Okay, what to do then? Or I could start kcalc in other ways, like from krunner, or from the terminal. Let's start it from the terminal, like this. Okay, what does the procedure say? So we have the name of the executable that crashes, and since the application kcrash doesn't really in reality crash every time, I don't know how to crash it every time. I know how to crash any process by sending it the zigzag signal. And that's what we're going to do to simulate that we can reproduce each time the crash of the application kcalc. But in reality, when we say please reproduce the issue, you should use the correct process name, so not kcalc, and you should use the correct way of reproducing the issue, not send it zigzag. Okay, and most of this information that's in this wiki page chapter is from this, originating from these two wiki pages from the Ubuntu wiki. Okay, so it says that the first thing that we need to do is to add in etc/app/sources.list.d a new file which is called ddebs.list, which should contain these three things. So let's do this first. Ctrl+Shift+D to get a new console terminal, Ctrl+Shift+V to paste. Asks for my sudo password and says that the following three lines were written to this file. So let's look if that's the case. Okay, so we have added the file, and now we need to install one package. And then we're going to run apt-update because we have three new deb file repositories added to apt. So apt needs to download the metadata, so the list of available packages from the repositories. This ddebs.ubuntu.com. Okay. But this just says that apt can now install 10,000 ddeb files. We don't know which ddeb files to install. Depending on which application is crashing, we might need to install different ddeb files. Depending on which codecs, which image plugins, which Qt modules are loaded in the process, which KD frameworks are loaded in the process. Many things could differ. So that's why we don't install ddeb files first, but first we generate a core dump, a crash dump, a core, and then we tell apt to install all of the ddeb files which are relevant for that core, for that crash dump file. Okay, so let's close kcalc. So we know how to crash kcalc. Now we can start kcalc in GDB, the debugger. It says enable debuginfod for this session because on Ubuntu 22.10 where debuginfod is available. But this procedure is what to do when debuginfod is not available. So let's choose no this time. The simpler way to do it, to generate a useful crash report backtrace, is to use debuginfod, but in this case we're going to not use debuginfod just for demonstrations purposes. So enable debuginfod for this session, no. Okay, back to the procedure, and then it says that at the GDB prompt we should write run. Okay, so kcalc starts. So says wait for the kcalc window to be shown and finish loading. This is it. Reproduce the issue and crash the KD process in another terminal. Let's do that. Ctrl+Shift+D. Let's just run this. So we send the signal zigzag to all of the processes that have kcalc in name, and says that it has killed the process kcalc with process ID PID 3699. It has actually sent it zigzag, which is signal number 11. And now in GDB, it says that thread 1 of kcalc has probably 3 threads, the process. So the main thread, the UI thread, the QtUI thread, has received a zigzag, so a signal, which is called segmentation fault. And the function that the main thread 1 was in at the moment where zigzag was received is gi poll. So from linux/poll.c. So this is probably, I know, from either from glib, which is the GTK library, or from glibc, which is the GNU-C library. Okay, so it said that it has crashed. Now we're going to do these things. Paste each and every one of them. And then press enter. In the home directory, which is // we will generate a file named core.core, which is a core dump of the process kcalc. Okay, as has saved core file to /home my user /core.core. Some of the memory bytes could not be read, which is okay. We're not running this as root, and maybe that's the problem. But we should not run this thing as root. Copy and paste. And now we're exiting GDB. Quit anyway, yes. And let's make sure that in the home directory we have this core file. Okay. So in my home directory, there's a core.core file. Now we're going to issue a command line that looks inside core.core, sees which .so files are loaded, and it will install the dbgsim file, ddeb file package for each of those .so file shared object files, dynamic libraries. Debian goodies. Paste. Okay, what did this do is it has looked at the file core.core. It said that it could not find -dbgsim.ddeb files for these .so files. That's not a problem. And it has found -dbgsim.ddeb packages for the rest of the SO files, and this is the list of packages. So the -- parameter just tells me, this executable find dbgsim packages to list, whereas the -- install parameter will tell it to try to install the list of packages using opt. Ctrl+Shift+V. Okay, it says that it failed because the list of packages, this is long, and one of these packages does not exist. Not a problem. We'll shrink the list of packages. Okay, it says if it fails to install the dbgsim ddeb package with an error like the following packages have unmet dependencies libexpect1, doesn't matter which package could not be installed. In this case, it's libexpect1. We just remove it from the list, not this thing. So this package doesn't exist. Ctrl+C, Ctrl+F+V, copy, Ctrl FV. So we're just removing this package from the list. Okay, the command already contains apt install, no install recommends. So let's run this command line, but without this package. Okay, Ctrl A, Ctrl C, Ctrl Shift V, go. So it says that I'm not a super user, so I need to append sudo to this thing. And so we have added the ddeb repository. We did apt update, so the metadata, the list of packages, was downloaded locally. Now we went apt install a huge list of packages, and now it's downloading them one by one. So as you can see, inside of the kcalc process, there were .so files, dynamic libraries for KF5, which is KD Framework version 5, these things. For ICU, which is for internationalization. GPU, this thing. This thing. GPG, GNU, encryption, suit, harf bus for fonts, GCC, the GNU compiler suit, fonts, GPU, LLVM probably for GPU also, CMS, this is for, I don't know, for color management or something, LZ, this is archiving, LZMA archiving, MPFR, multi-precision, floating point library, OGG, which is audio codec, Perl, compatible regular expressions, PNG, image codec, Qt SO files, the C++ standard library from the GNU GCC, GNU compiler collection, udev, systemd, Vorbis, which is an audio codec, Vorbis file, WebP, audio codec, not image codec. Okay, X11, Xorg. Okay, this is for color conversion, archiving, etc. So huge list of .so files existing inside of the kcalc process. So a huge list of ddeb.deb files needed to be downloaded. Okay, so the names of packages are like -dbgsim, and then they end with ddeb.deb. Okay, so it has downloaded all of these files, these packages, and installed them. Okay. What's next? So we finished successfully this part and this part. It says generate a backtrace from core. Let's do that. Ctrl Shift V. Okay. So we waited as much as possible. I'm on a fast SSD, probably on slower hard disks it takes even more time So running kcalc under GDB is slower. Again, it asks if I want debugging for the I'm again going to go no. I'm waiting until I get the prompt round parentheses GDB, which this is the case. So it says that it has looked inside of the core.core file. It saw that the process running was kcalc and that these many threads exist, and at the first thread this function was running and the signal zigzag segmentation fault was received. Okay, and now we run this thing, or this entire thing could have been replaced by this thing. So let's first do it line by line, and then we're going to do it from just one line. Okay, set trace commands on, Ctrl+Shift+V, set logging override on, Ctrl+Shift+V, set pagination on. So pagination means no paginator, so like more or less. Okay, so what we did until now, it was to tell GDB whatever it writes to the standard output, it should also write into my home directory in the file backtrace.txt. And then it needs to create a backtrace full, which creates backtrace, I don't know, probably for just the current thread, so the thread 1. Then I'm looking at the CPU registers, which look like this. I'm on an AMD 64 machine. I'm looking at the local variables in the function where I was at, which is that GI poll thing. And then I'm going to look inside all of the threads, which is probably 3 threads in this case, and look at the call stacks inside of all of those threads. So there's 8 threads, 7. So thread 7 has this call stack, thread 6 has this call stack, etc. until the thread 1, which is the thread where the main loop exists, so the UI painting loop. That's the way it's implemented in Windows, the main loop. The GUI main loop is on thread 1. Okay. Then we can go quit. And now we have in my home directory a file called backtrace.txt, which contains all of the file that should be put inside of the bug report. You probably want to paste the entire content of the file inside of a comment in the bug report, not attach it, because if you attach it, then it's not going to be searchable. So let's look at the file, see how it looks like. Backtrace.txt. Okay. Let's put some colors in here. So each of the commands that it has run, like backtrace full, was echoed with plus backtrace full because we say trace commands on. And then this is the command that was run, backtrace full, and then this is the output. So this is in fact a call stack the deepest function, which is the last pushed on the stack, the one that's going to be popped. Then this function was called from this function, which 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 was called from this method, which is called from this function, this function, this function. And the very first function that was pushed on the stack on the thread 1 is the entry point of the executable, which is the function with name main in kcalc.cpp file. Okay, for each of the functions it says its signature, so it says the name of the file, the line, and then signature, and then the arguments of the function. So this function was called with two arguments, argc and argv, which both were optimized out. We have debug symbols of the .so files and of the executables, but still these executables were, and the SO files and in general ELF files, were compiled with rel with debuginfo, so release with debugging information. Many things are optimized out, but we still have debug info. Why optimized out? Because we want performance, we want to build in release mode such that we use the least amount of, when we run kcalc application, we want to use the least amount of RAM, of hard disk space, and we want the process kcalc to be as fast as possible. That's why you use optimization. Okay, and then for each of these functions, we have all of the local variables. So it says that inside of the main function, we have declared a local variable, which is called app, which is of type QGUI application, which contains a QCore application, which is a QObject, etc., etc. The viewing is not that great for objects, it just contains a ton of pointers. So again, local variables and function call arguments, function call arguments, and local variables. Next, after we run backtrace full, we run info registers, so the command that was run, the standard output from that command, and then we want local variables, which was already gathered by backtrace full. Then we do this thing, and then we do for each thread apply all backtrace, maybe it should be apply all backtrace full. Okay, so thread 1 is what we saw previously, this thing, and the rest of the threads from 2 to 7. Yeah, this probably should be a thread apply all backtrace full. Okay, so that's the way to create the correct backtrace by running each command one by one. If we don't want that, at least this last chapter, the generate backtrace from core, this part can be replaced by this part, which will do all of these lines at once. So Ctrl-Shift-V, and let's rename the file in here. To see that the correct, the same backtrace file was generated. Let's name it backtrace2. Okay, so it does its thing. it takes a while to load, start the process, load the SO files, load the debug symbols, run the process, etc. Okay, and now let's look at the two files. Where are you highlighting? 3DGLSL. Okay, backtrace full. No, where are you? Info registers, info locals, PC, thread apply all backtrace. Looks totally the same.